Okay. Mm. Sure, guys. Mm. Okay, sorry, guys. So today's video is the Buffon needle experiment as a model of space and time. Model of space and time. Or the theory of everything. The theory of everything. Now, the theory of everything is my theory, Buffon needle experiment. We have a pin or needle, you have a needle equal to this that cuts the lines evenly. As long as the needle, but it's an infinite grid of lines. Now you have space. You have space. This piece of paper. I flat to this space, and you have time. Now, time is a needle. Can't find a needle here. Yes. So you have a model of space and time via the within model experiment. But I'm not talking about physical space. I'm talking about calculus one and calculus two as a studies video. But this is a new video on space and time. This is my model of the theory of everything. If I ever do die, what I'm saying, you know, the goal is to have a framework for the space and time duality. 1 second, let me get something. Take take this lines of paper. They represent space, but and time. But when these two things and the solution, the needle, can't I do a needle here? Come and find my phone pin. Uh, you have a phone pin here. So this is like a needle, this is like a needle, and this pen, this is a needle that's long as these lines, then, because I can't find actual pin now, you can see that in between these lines, this A4 lines of this A4 sheet of paper, there's literally lines going across, evenly. But if you have infinite position, even like you have a smaller needle, so the space is also equivalent to the time. But what if the time keeps going? Now, the time doesn't can moves away from you. So time moves away from you. So this beautiful needle experiment shows that space time exists. But the pen, or this needle, this pen, or this needle is in a situation of state of time. It's just basically in my hypothesis, I think there's a universe, there's a 3D universe that's literally not our own, but everything has to have space and time. It's a homogeneous, heterogeneous universe, because every kind is parameters and this is stored. But our universe is a heterogeneous, homogeneous universe. So I'm trying to model this properly. I won't do the maths today, but I'll give you the framework to use it. If in case I die in the wood, it does happen. Uh, if you have this needle and it falls this paper, yeah, it goes and it keeps going, and this paper doesn't move. This paper is just a pen. This is time moving through the space. Now you can always measure time. Doesn't matter where you come from, you can tell the time. If you're foundational mathematics, but a child can tell the time. You see, but space and time are intermingled. You can have time. This time can also be told, but you can't measure it always. You can measure with infinite precision, uncountably infinite precision. In basically in a homogeneous system, This framework doesn't exist. What exists is time is static. Time can be equal to space. You can have a measurement of time equivalent to the area of space with countable precision. So, for example, if you have, I'm going to say this now, if you have an area of 4 minutes and 4 minutes, 4 times 4, you have 16 minutes. Now, that's this is space in centimeters or whatever units you're using to measure the space. That's equivalent to that time. 14 centimeters, so if you have 4 times 4 centimeters of space, you have 16 centimeters squared. And that has the time in a countable, heterogeneous, homogeneous model. I am proposing that space and time follow two main principles. What do I write down? If this works, this is the river needle. This one, I just love the river needle. You have to understand. We'll write it down. Time is measured, space holds everything, and time doesn't. The time, because when time meets space, when if we do this time, when time finally meets space, our frame of there'll be a drift in space, and that's something going to hold something. You have a space, and the space is basically the time at an orthogonal, the drift theorem, meeting the time. So, for example, you have the time, say the drift theorem. So, if I'm what's the drift theorem? I mean, my invention. I feel like a crazy madman, but let's say I'm autistic. So, if I'm moving away from this camera and I know I'm moving away, I'm drifting, and I know I'm drifting, because the drift theorem states that everything in the universe has a natural tendency to drift. This is a drift away because I'm moving away from my laptop right now, but I'm moving at an angle that is orthogonal, opposite drift. This is opposite drift. I can drift towards you, or I can drift at a right angle. Now, this orthogonal drift means it's a 90-degree drift, or I can move at 45 degrees. Now, if I move at 45 degrees, I'm moving away from you, but this is what is called redshift or double shift. It's basically the effect of the system of Doppler wavelength. And my theory of everything is matter holds something, holds nothing. Not our universe need to hold anything, but it's something for you to hold. So, for example, you have heterogeneous one, so you gotta have homogeneity, which is basically a time kind, but a type of something. A woman is a type of man. A cat is a type of mammal, and a cat relationship. But the homogeneity lies in the type classification of space and time, and the heterogeneous model lies in the kind, the kind of data, the kind of the variation of the system. So our universe allows for variation of accurate modeling of space and time, but we may never be fully to measure a system of time unless we include space in it. We never because in all system in the old universe, in the non-bubble, in the bubble countable universe, the square is equal to the time. You can have an area, but it's countable. It's countable because the Buffon needle, the area of the square, or the surface of the rect-shaped universe, the bubble-shaped universe is a bubble universe, a 3D bubble universe, will have a volume that has a mass, but with the same precision they can output based on the countable set. But our universe are uncountable and it's heterogeneous or only homogeneous. If something breaks, if the physics breaks, but that would never happen. It may possibly happen, but I'm saying that it's possible for that to happen. But the drifting of the needle itself, the pen I'm holding as a needle, will have to pop into our reality and come out as a redshift or Doppler effect, like a car moving away. This is called the drift theorem. So the drift theorem is modeled most specifically as changing. Basically, you get the Lorentz factor B squared minus 4. I love this discriminant. I can say the B squared over 4AC. But you have V squared minus C squared. So you're going to have the drift, which is a position P of a camera position C minus T minus P minus C, where C is a camera of time, equals dt. Now, the derivative of basically that's the derivative of time. No, the drift of time is a position of a camera C, which is observer, minus the after you formula minus a camera C. So a position minus a camera T. T. So T of time, where time is the factor of angular momentum. So you can notice the time formula there, the time in there. And time is relative to an observer. And that observer is actually things that I have the terminal to move away if they have a camera on top of them. So the formula is like this. One, basically you got the weighted average of 2 points, which is the geometrical equivalence, very important, one half with one T times. No, let me start with the system. So you have two models of weighted average, and weighted average is defined as one half two-thirds T, two-thirds T times one-third P, two-thirds P times one-third T, plus one-third T. No. Two-thirds C. Two-thirds P. So two-thirds of P, which is the predicted point, and plus one-third C, which is the camera point. Now, the drift theorem says that things moving away is D. D, so the weighted D weight equals the geometry. Now, geometry, two-thirds C plus one-third, two-thirds P plus one-third C, which is geometrically the space between the needle and as it moves away is the area, But since the pen, imagine the needle now in a superposition, it doesn't know whether it occupies space or occupies time. This pen will have to be this is both space and time simultaneously because it doesn't know. It just goes in space and time. No consciousness here. It just doesn't know. So this needle determines whether whether to fall. So if you define this properly as a trait, this is a trait, and traits are modelable like traits are behavior specifications. So you can have a macro that does something that involves a trait, like a Ross trait. Ross trait. So Ross, this is all basically the goal is to have a behavior, a glider or flyer, what I call a classical superposition. This means that the trait is metadata for a model for data, metadata for data in a model. For example, you're gonna have a glider. A chicken is a glider. It is not a flyer. It can't fly like a bird, but it's a type of flightless bird. So is it a bird? Yes, it's a bird, but it's a flightless bird. It's called a chicken. And that's the model of a glider and a flyer that has a trait of a phenotype, phenotype, and the genotype, the same genotype, but it's different phenotype from a bird. So the guidance example I'm going to give you, first example, an example I'll give you is superposition. Now, superposition is this what state is this? What pen is it? Is this if it's half on, it is half off. This is called a half switch problem. If it's half on, it's half off. And until the time runs out, the superposition exists. This is what I'm saying. This pen represents time. Because as soon as I want to drop this pen, as soon as the pen falls in space-time, falls like this, it's basically, it will not fall until the state of half falling, basically Think of it as spin up, spin down, spin up. Is it spun up? Is it spun down? Now, if it's spun up, it means it has a little to hold, hold. Because if it's spun down, it has a little to drift towards us, drift towards our universe, which way space is created in time. This is what I call the Big Bang model. So the Big Bang model connects space and time, and the theory of everything is born from this model. It's my theory of everything. And I'm saying, claiming that, I have to do further research via the Buffon needle, but because the Buffon needle slices the pen, slices dimensions, and the more precise you get pi, you compute pi using the Buffon mental space. It is not a joke. 2/3 of the lines are slit in 2/3. Two-thirds, which is 64 point 2/3 of the time. The percentage of the pen, if the pen is as equal to the line, you get the lines of the pen. And the model models the space, as time and time and space. The superposition concept is not a joke to me. It's the trait, and the trait are macros that define behavior logic of a program. The program is not the algorithm defining, it's the flash. It's a behavioral, it's the trait enforced behavior that's defined as a state of supervision in my model. So traits so you have you can measure an algorithm coherence via an A star part, and what's wrong, what's not wrong, what's benchmarkers. But I'm saying to you the degree of centrality and all that. But I'm saying to you in this model, the trait is one important key feature of the supervision in the calculus system. Because you set them to random, like half on, half on. If the time and then that time runs out and the pen doesn't fall, that means this structure holds, and this there's no space at the bottom. But the goal is to have the system, the pen drop down to model to get to have some kind of allocate bytes in the system of memory. So it's basically I have an arbitrary allocation of bytes, and it should work and just do everything. I know it does work because I'm very smart and been doing it for so long. But you have to model space from time. The time the pen drops is based on the decay of the superposition. The key word is decay. Superposition, decay. If the superposition, if it's basically in a state of half up, half down, and it does randomly drift, spin up and drift towards us. It will drift towards in one angular momentum, which is a wave. You have redshift, Doppler shift, sonar, things that allows you to make a measurement based on compression and depression of the wavelengths, amplitude and frequency, and oscillate back and forth energy. And energy equals mass times the constant of gravity squared, Planck's constant, the width of gravity. You get things that because there's nothing that was literally held to create it. It was created by the lack of something being held, or the pressure of a universe, that wanted to hold everything together. For example, that's not how let's call it a homogeneous heterogeneous universe. So I'm claiming there's two types of universes. There's a homogeneous heterogeneous universe, which requires time for space and space for time. There's one that requires time and no space to execute, like algorithms, physical storage in kind of matter and space. So you have the drift, and the drift is the double bind. So the drift is very important for me because it establishes some foundation of where I am in the universe, in the bubble universe, or the bubble theory of the universe. Now, the drift theorem says that we have a big crunch before we have a big bang. The big crunch is gonna shrink our universe by a half, and then gonna explode, and that's what we have. Big Bang. But we measure the Big Bang because that's the closest, that's basically our universe expanding. That's the model of expansion. But why is the universe supposed to? No, it has to deflate. Maybe to deflate first because it expand. Because the rationale does not kick in. You know, you have to crunch able to deflate something deflatable in some other realm, which is the other universe. So the other universe imploded, the other universe imploded, our universe exploded. And we're measuring the explosion of after the implosion of the universe. Because this is a long time now ago. And it's possible, this is what you can do this probably. But that's to say the big crunch is what happened before the Big Bang. So, because there was no space until there was space for space. That's what I like to say. So you're gonna have the drift of a system. Drift away, we are moving away, and drift towards me going close to my computer screen. Drift at a right angle, drift further right angle, off screen. Now drift, keep drifting, and drift away, drift closer at right angle, and now facing the camera again. But now drift angular, drift at 45 degrees angle. Now I can put myself here, but this is we are a kind type universe. The pin represents the geometry lattice over half p, 2/3 p times 1/3 plus 1/3 c geometrically, and you can have 1 minus t times c plus t times p. Now t is 1 minus t is the algebraic form of the measurement. So the systems are isomorphic, they do the same thing, but geometry equals space. Space, two sets of if you're doing geometry, or concentration of the universe. If you measure space with time, you can measure the system of one region perfectly. And this amount of a cryptographic receipts. If the space is countable, you can count every Cartesian coordinate system, or you can count any continuous system, or you can have a set of precision points you can always enumerate. You have a universe that is homogeneous, type first, kind next. Type first only, kind next only. Again, and that's what I'm saying. Our universe doesn't break. You cannot break a universe unless you break the structure in it. And create some world or something. You don't want to break a universe anyway. You want to open and close portals, but where is the space for the portal to be? It requires so much energy. It's possible to open a portal in media, but as we use it out there, but the energy will just collapse and stuff. You should open a portal in a homogeneous first only and homogeneous only next. So this is a kind of a pet, kind of a mammal, on top of the system.